So here are the exercises for section 3, and what we're going to start talking about is this long division process. And what you see here is a problem that says to divide 2x squared plus 10x plus 12 by x plus 3. So what we need to do is we need to write down this whole expression. We need to divide x into 2x squared. Now if we divide 2x squared by x, it has to divide evenly, and it does because we can take out an x and we're left with 2x. So 2x goes into 2x squared if we divide it by x. So I take this 2x and times it by these two things to get 2x squared plus 6x. Now I have to take this whole thing and subtract it. So I'm going to take 2x squared and subtract 2x squared. They cancel out. 10x minus 6x is 4x. Then I carry down the 12. So then I have to ask myself, does x divide into 4x? The answer is it does, because I can cancel out the x's and it divides in 4 times. So I write down plus 4. So I take 4 times x plus 3, I get 4x plus 12, and I subtract that. The 4x cancels out, 12 minus 12 cancels out. I'm left with no remainder. So my answer for this is 2x plus 4. Now a little bit different one that doesn't have all the placeholders in the problem, x cubed minus 27. Very easy to write down just the x cubed and then the minus 27, but you have to make sure that all the missing placeholders are accounted for. Because if you have missing placeholders in whole numbers, you put zeros there, just like if you have missing placeholders in expressions, you put zeros there as well when you divide. So I divide x into x cubed, I get x squared. X squared times x is x cubed. X squared times a negative 3 is a negative 3x squared. I subtract these two things, and I get a positive, because the negatives cancel out, I get a positive 3x squared. And then I'm going to carry down this 0x for now, even though there's really nothing to carry down, but I'll carry it down just so we know what we're subtracting. Now I'm going to divide x into 3x squared, and I get 3x. So I take 3x times x to get 3x squared. 3x times a negative 3 is a negative 9x, and I'm going to subtract these two things. These cancel out. A minus a negative 9, so 0 minus negative 9 is a positive 9x. Carry down the negative 27. I'm going to divide x into 9x, and I get a positive 9. We take 9 times x to get 9x, 9 times a negative 3 to get negative 27. And then going to subtract these two things. It is nothing left, so there is no remainder. Here is my solution. Now they write things a little bit different in order, so we just have to make sure we deal with it the right way. So I have 2x cubed. So I write that first, then the negative 8x squared, then the 3x, then the minus 9. And I'm going to divide that by, notice we have an x squared now, so this is going to be a little bit longer term. I'm missing a placeholder, so I got to put that there, plus 0x plus 1. So when we divide this, just to make sure it looks the same, We divide x squared into 2x cubed. We get 2x. I take 2x times x squared. I get 2x cubed. 0x times 2x, that's going to be nothing. 1 times 2x is 2x. So I subtract all of that. This cancels out. I'm left with negative 8x squared. A negative or a positive 3 minus 2x is left with a positive x minus 9. So I carry down the negative 9. So now I divide the x squared into negative 8x squared, and I'm left with negative 8. So I take everything, times it by a negative 8. I'm left with negative 8x squared plus 0x minus 8. So I'm going to subtract all of this again. That cancels out. I'm left with x. A negative 9 minus a negative 8, that's negative 9 plus 8. I have nothing else to carry down, so this is my remainder. So here's my remainder. So the way I write this, anytime you have a remainder, it's left over what you are dividing by. So my answer for this is this whole thing here. That's my whole answer. This whole thing. Now 27 is a lot easier because they're asking us to use synthetic division. So very quickly, synthetic division is just a product of using the coefficients. So I'm going to write 3, negative 17 in order, 15, negative 25. And I'm going to put in this upper right hand corner this 0 of this, or the opposite of the number you see. And what I need to do is I first carry down this 3. Then I times the next column by this number and the number that's remaining, so that's 15. Then I combine those two things to get negative 2. This becomes a negative 6. So there's 9. Times it by, oops, I need to make sure I'm multiplying these right. This is a negative 2. This will be a negative 10. So that will be 5. This will be 25. So this will be 0. So my answer for this is my constant, and then it goes up from there. This is my linear term. This is my squared term. So it's 3x squared minus or plus a negative 2x plus 5. So my answer is 3x squared minus 2x plus 5. There's no remainder. And another way to look at it is to know that 3x squared minus 2x plus 5. When you divide by something, that means if you multiply by it, by what you're dividing by, you're going to get this thing here. But this is what you get when you use synthetic division. 55. I'm going to talk about just a couple of these, just so you can get the hang of it. There's a lot of parts to this, but very quickly I'll explain to you what 55 is asking. So 55, we have a function. It says 2x cubed minus 7x plus 3. And it's asking in letter A to evaluate this and what that's equal to. Well, to use synthetic division, all we got to do is pretend like we're dividing in synthetic division with that number. So I'm going to put 2, then 0 because there's no x squared, then negative 7, then 3. So I'm going to drop down the 2. This becomes 2. This becomes 2 here. Then it becomes 2 again. This is a negative 5. This is a negative 5. And this is a negative 2. So when you use synthetic division for a function, the remainder is what the function evaluates at for that given number. So at 1, it's equal to what the remainder is, which is negative 2. And you can do this for any number. Letter B, it asks for negative 2. So I'm going to put that in and see what happens. So that becomes negative 4. This becomes 8. So at negative 2, it's equal to what the remainder is when you use synthetic division, which is 1. Now 67, it says to verify the given factors of the function and find the remaining factors. So what I'm going to do is verify that these are factors and then find the remaining factors. So 67, our function is 2x cubed plus x squared minus 5x plus 2. And it's given me two factors, x plus 2 and x minus 1. Well, let's see what happens when I divide using synthetic division. So I'm going to put a 1 there because if I divide by using synthetic division, I'm going to put a 1 because it's the opposite. Now if I use synthetic division, let's see what I'm left with. So this is a 2. So I'm left with 2x squared plus 3x minus 2. So it divides evenly. If something divides evenly, it's a factor. Okay, so it's a factor of this. So now we know one factor, so I'm going to divide it even a little bit further. I'm going to divide by the next thing, but I'm only going to deal with the part that's remaining, this negative 2. Let's see what happens. Again, we get a remainder of 0. No remainder, divides evenly, it's a factor. So what this means is that these two are factors. The one that's left after dividing both of them out is right here. Here's my constant term. Here's my linear term. It's 2x minus 1. That's the remainder, the remaining factor. Now, if we wanted to find the zeros of this would just be the opposites, or what makes each one 0. In this case, it's negative 2. We use negative 2 here. Whoops. This one here would be 1. If I wanted to find the 0 for this, I'd set it equal to 0, but it would be 1/2. So here is the complete factored form of this. Those are all my zeros, and you don't have to confirm with the graphing utility because we have the answer right there.